In the previous videos, we learned that if we have a mathematical equation, we know how to convert or how to make it as a controllable canonical form or observable canonical form or Jordan form. So controllable canonical form is nothing but the input is well connected with the state variables x1 and x2, x3. Same thing with observable canonical form, output is well connected with the state variables. Okay, and Jordan form is based on where do you keep that constant parameter. It could be either controllable or observable or both. Now, how do we do if we want to convert a controllable canonical form into observable or observable into controllable or Jordan into controllable, so vice versa? I mean, we know how to find a transfer function h of s by using that ABCD matrices. Then from the transfer function, it's similar to mathematical equation. We can find controllable canonical form, observable canonical form, Jordan form. It's a kind of long process, but by using state transformation matrix T, we call that as T. By using state transformation matrix, we can convert one form to another form. That's what we're going to learn in this video. Now, do not confuse with state transition matrix with the state transformation matrix. State transition is e to the power of at. Okay, a state transformation is, we're going to see how to find T matrix. Now, say for example, x dot is a state equation, ax plus bu, y equal to cx plus du. This is output equation. So we got these two equations from a given model, either controllable canonical form, observable, or Jordan form. Now, I'm going to take, let x equal to t times, where t is the state transformation matrix, x cap. X cap is the new state variable. Okay, x is the old state variable, x cap is the new state variable. Now, based on this, x cap equal to t inverse times x. Now, I'm going to substitute x equal to t times x cap in this given state equation. So t times x cap dot equal to a times t x cap plus b times u. Okay, so if I bring the t to the other side, or if I multiply this with the t inverse, it's going to be something like this. Okay, so x cap dot equal to t inverse times at x hat plus t inverse times b u. X cap or x hat doesn't matter. Okay, so x hat dot equal to a cap or a hat x hat plus b hat times u. Now you can see clearly a hat equal to t inverse times a times t, and b hat equal to t inverse times b. Now if I substitute the same thing, y equal to cx plus du. Now if I substitute x equal to t times x cap or x hat, so c hat equal to ct. Okay, so we need to remember, so if you know a b c old matrices as well as the T transformation matrix, we can find new a b c matrices. Now, how to find T matrix? Okay, that's a state transformation matrix, T matrix, for a controllable canonical form. So for each method, a controllable, there is a way, observable another way, and Jordan form is another way. So now we're going to see how to find the T matrix for the controllable canonical form. PC equal to, we know that controllable matrix PC equal to b a b a square b etc a to the power of n minus 1 times b. PC hat equal to b hat a hat b hat a hat square b hat etc up to a hat n to the power of n minus 1 times b hat. Okay, that's what it is. Okay, now I'm going to substitute b hat equal to t inverse times b, and same way a hat equal to t inverse times a times t. Okay, so t inverse times a times t, t inverse times b, t inverse times a times t, T inverse A times T inverse times B. Now T and T inverse, they get cancelled out. T inverse, T inverse. So you will end up with T inverse times B, T inverse times AB, T inverse times A square B, etc. etc. So if I pull out T inverse, so PC hat equal to T inverse times PC. Now if I multiply T with T both sides, you will end up with T equal to PC times, or T equal to PC times PC hat inverse. This is the state transformation matrix for controllable canonical form. Okay, when it comes to the observable canonical form, P naught equal to C, CA, CA square, CA cube, etc. etc. Now P naught hat equal to C hat, C hat A hat, C hat A hat square, etc. etc. Now I'm going to substitute C equal to, or C hat equal to CT. Okay, now I'm going to substitute that value here. So CT, CT, T inverse of AT. So T and T inverse get cancelled. T inverse get cancelled. T inverse get cancelled. So we will end up with T times CA, C, CA, C, A square, etc. etc. So I can see P naught hat equal to P naught times T. So to get T must be, I'm going to multiply with P naught inverse. So T equal to P naught inverse times P naught hat. That's a state transformation matrix for the observable canonical form. Now finding the tree matrix for the Jordan form. Jordan form, we already learned that in the previous video, how to find the Eigenvector matrix. So the Eigenvector matrix is nothing but the T matrix, state transformation matrix for the Jordan form. So if you have A equal to 0, 1, minus 2, 3, find determinant of A minus lambda I, find and make it equal to 0. Once I have that, I have lambda equal to 2, lambda equal to 1. Now these are called eigen values. So to find the eigenvectors, substitute eigenvalues in A minus lambda I. So I substituted lambda equal to 2. Now minus lambda 1, minus 2, 3 minus lambda equal to v11, v21 equal to 0, 0. So if I substitute that, you end up with these. I mean, both of them are the same equations. It must be the same equation anyway. So choose one of the value, any value. So I chose vt1 equal to 1, end up with v11 equal to 2. Okay, same thing, substitute lambda equal to 1. So you have two values, lambda equal to 2, lambda equal to 1. When I substituted lambda equal to 2, I end up with these two numbers. Now lambda equal to 1, I'll find v12 and v22. So I end up with I found those values. Okay, so we have to choose one value anyway. So I end up with v12 equal to v22. Both equations are same. Okay, choose one value. I chose one value, v12 equal to 2, then v22 equal to 2. Should I choose 2? No, it's up to you. You can choose any other value. So the state transformation matrix for the Jordan form is, this is state transformation matrix. Okay, so now in the next video I will explain how to convert from one method to another method. Thank you.